Thanks, Sharon. It's I think one of my happiest moments here, come here today, and Professor Ho, we celebrate so for his long, sort of successful career, and I think I benefit two things from him as a student when I was at Harvard. One, of course, obvious without saying, is doing research, how to do research. I think it was talked about a lot earlier today, how to do good research. The other thing is how to be a good person. I think often these days when I do things, I sort of thinking back, oh, this is how we learned at Harvard. So I'm really happy to be back here and to give a talk at this seminar to celebrate my advice, sort of the long distinguished career. And of course, I thank David for organizing this session. David and I went to Harvard together. Of course, he has as a faculty member, I as a PhD student. David also was in my thesis, the defense committee, thesis committee, and I still remember that, how hard we work at Harvard. I think I defend my thesis on Saturday, so we work on Saturday as well. For those of students that probably these days people don't work as hard as we do, but still, Professor who always criticize us not working hard enough. So even we work on Saturdays, but really I think that there are also a lot of questions about how to myself as faculty member. So we also have a lot of students, and the question is how to educate our students. Question earlier asked how to encourage our students to be in academic life. Actually, I remember one little story. I still remember that. I don't remember if I give my defense or in one of the defense at Harvard. Someone asked Professor Ho, how do you decide to let a student to graduate? I still remember there's 3 criteria. One is that Professor Ho said that I have to be proud of my student, one criteria. The other is that his work has to be recognized by the community. The third thing is that I have to learn something from the student. If student can meet any of one of those 3 criteria, I decide he can graduate. So, 2. So now I think my standard is lower now. So that just shows that how things we learn from Professor Ho, and also earlier that Yemi mentioned that Professor Ho's the vacation house in New Hampshire. I still remember that every year that Professor Ho would invite us as a student to go there to spend 1 or 2 days there. I still remember the cross-country ski, the marshmallow, and also the games we play while we stay there. So all those fond, good memories. Really, I really appreciate that all those things that I had enjoyed at Harvard. And of course, most importantly, I think Professor Ho taught us how to enjoy life, basically. It doesn't matter whether you're in academia, in industry, anywhere. So I think very important, just do what you like. I think enjoy life. I think that is the most important thing. Actually, even though most of us as Professor Ho's student are in academic, I still remember that actually in early days when one of our friend, Xu Li, he eventually went into industry. Professor always talk about him, so when he is our example, you see, he brief enough to go to industry. And so doesn't matter where you go. I think that as long as you're happy, that is the most important thing. I think this is one of the things that I learned most, I think, from Professor Ho. Of course, it's getting tougher to give talk here, because also I always very nervous when I give talk when Professor Ho is in the audience, because you can see that when she didn't give a talk, Professor Ho was criticizing him, asking him, what he should do. So I think that actually this is one of, for all the students here, actually this is one of the things I learned from Professor Ho is it's extremely important to give good talks because you don't get many opportunities. Probably this stage, even more these days, people really don't read your papers. There's 3 people, maybe 4 or 5 people read your papers. That the reviews, that's it. Only when after people give you presentations, give you talks, and listen that it's a possibly good piece of work, then they will go back to read your paper. So it's extremely important. So I was thinking that I should revise my slides PPT when I get a chance last night, but unfortunately I came here really late. So hopefully that I can still meet Professor Ho's standard for giving a talk. This is one of the examples that how would you find a good research problem. Actually, I sort of view this as one of my hobbies. And so when I came back to Shanghai to Fudan University, so I have seen actually a lot of interesting problems. And this is one of the problems I have seen. Of course, I was thinking, I was doing some consulting. I think maybe along the line, I can make some money as well. But be careful, okay? So the stock index future was first introduced almost 35 years ago in US as SP500 futures. I think probably most of people here know. Oh. And since then, stock index future has been introduced in many different markets. It was introduced in China 7 years ago to 2010. Okay. In general, one of the important problems, futures are considered the financial derivatives because itself is not a real asset, right? It's based on something else. So one of the important problems in finance is how to price the financial derivatives since they are based on something else, okay? So to price the stock index futures, there's the standard method. One of them probably most often used is cost to carry model. So you basically, this was done 1983, okay? So this is pretty standard model, okay? Essentially, in the cost of carry model, you treat the stock index future as a forward contract. Okay, so essentially you try to figure out if I hold a stock index future contract, how much it's going to cost you. Okay, so this is how much you should pay for that. Okay, cost including, of course, it's related to the underlying stock index cash value. Also relate to the cost, the capital cost. Okay, so that relates to the interest rate. And also relate to the dividends because stock index future, if you hold stock index future, you don't get the dividend payout. So that is part of the cost as well. So if you figure that out, and also based on the assumption there's no arbitrage, okay, so you can figure out what is the price for the stock index futures. Okay, so there's several key assumptions in the classical cost of carry model. Okay, one is the risk-free interest rates are constant. Okay, the other is the markets are perfect because it's a no arbitrage model. So you assume that you can do arbitrage whatever you want. There's no limit on that. Okay. And also, it doesn't take into the consideration the impact of the volatility of market on the future price. Actually, there are a lot of empirical evidence show that the stock index future price depends on the market volatility. Okay, so all those the assumptions. Okay, so it was used in this cost carry model. So in this regard, in this model, the future price depends on the underlying index cash price, the risk-free interest rate, the dividend yield, and the time to maturity. Okay, so this is a fairly straightforward model. Okay. However, because of those assumptions, there are some extend work in trying to extend this model. Okay. For example, in this model, that it's assumed that the interest rates are stochastic, and then there are models sort of incorporate both the interest rate and the market volatility as the stochastic processes. Okay. However, very few study on the effect of a trading and regulatory constraint on the index future prices. This is particularly the case because in China, there are a lot of trading and the regulatory constraints put into the market. For example, I don't know if you know what is the T+1. In U.S., you take in granted that when you buy a stock, you should sell it instantly, right? Anytime you want. But in China, if you buy a stock, you can't sell it at the same day. You have to wait for the next day to sell it. So if you try to do arbitrage, there's significant constraint. Okay? There are other constraints put into the market by the government agencies. Okay? I want to show you a graph. So this is what I talk about the Huseng 300. It's a CSI 300 stock index. So basis is defined as future price minus the cash price. So it should be equal to something based on the cost of carry model. Even you incorporate the fact that the stock, the interest rates are stochastic, the volatility, those factors. Okay, but if you look at this figure, you will see that, particularly in this region, this is within a month. Okay, so the difference is quite huge, up to 10%. I just think that within a month, if in a perfect market, you can do arbitrage so that your return is 10%. And this is much beyond the fact that you have a dividend payout, interest rate is even is 10% a year. So that consistently, the difference is above 2 or 3%.
So what's your y-axis?
This is the difference. The basis is a percentage, I'm sorry, as a percentage. So this is up to 10%. If you look at, if you follow the Chinese market, you know this is this huge volatility 2 years ago. Okay, so it looks like you have a huge arbitrage opportunity. I mean, it's almost like the return could be more than 50% and the risk-free, right? So this is what brought us our attention. See, we want to know what exactly is going on. Okay, so this is basically the background of this problem. Of course, if you look at other market, there are some deviations of the stock index futures from their cash values, but not to that extent. Okay, so maybe just some %. Okay, so this is huge. Okay, and it's very hard to explain based on the traditional theory, okay, or models. Okay, so this is the what we try to understand what's going on. Okay, how much time? I shouldn't pass my time because I'm the only person standing between these talk and the lunch, right? So it's always very hard, okay? So I have to follow the previous speakers. I have to use some formulas and notations. I hope I can explain this carefully. Try to follow the rule that less than 6 lines in every page, but I'm sure I violated that line in many pages. Okay. So this is the basic model. Okay, so we consider market with K investors, okay, with J risk assets and 1 risk-free asset. You can think this is the bond. Okay, so the investor is from 1 to K, the assets from 0 to J, 0 being the risk-free asset. Okay. So we consider model with 2 periods. PJ is the price of assets at time T1. XJ is the price of assets at T equal to 2. This is a random variable, so the return is random, right? And the R is the risk-free interest rate, and the NJK is the initial unit of asset J that invest K hold. So this is what you have initially, okay? And XJK is the position of assets J held by invest K after rebalance. So you start with something based on your objective, you will rebalance your portfolio, okay? Based on the expected return you have on each asset. Okay, so this actually is a classical assets balance problem. Okay, if the expected return for each investor is the same, then you have a homogeneous model. So this is pretty standard. The difference here is that we assume that each investor, the expectation on the return is different. So we have a non-homogeneous model. Okay. So,
quick question. So is the total number of units fixed?
Yes.
Okay. So all you do is you
Yes.
Why? I mean, why am I not
So that's why you have
more stocks or to sell some stocks? Why am I bounded by this fixed allocation?
Well, if you think that in the stock market, the number of shares available is fixed, right?
Oh, okay. I'm looking at it from the point of view of an individual investor.
Oh no, this I'm saying that the whole market is fixed. Yes, each individual will be different. So that's why these 2 numbers is the same. It's not same. This is the initial. This is the amount after the rebalance.
What's the difference between units and the position? Position is
Oh, it's the same. I'm sorry. It's the same. The number of units, I should say. So if WKT is a total wealth of invest K at time T, and this is obvious, pretty straightforward, right? This is how you, and we assume that x0 equal to 1. This is the P is equal to this. So just for standardization, okay. Without going to the technical detail, essentially, what each investor tries to do is try to rebalance his position based on some objective. So one classical objective is this is a return and this is volatility, right? So you want to, in general, a rational investor, you want to maximize your return, but at the same time you want to keep volatility low, right? Of course, you can have other objective functions, but this is the classical one, okay? So we take this objective function and alpha k is some coefficient. So if alpha k is equal to 0 means that you don't care about the volatility, right? But are there examples people like volatility? Probably, right? But in general. So this is the objective utility function for each investor. So what each investor tries to do is try to maximize this utility function, which will result to some portfolio allocation, subject to the market constraint, because total supply should equal to the total demand, right? The number of units for each asset is fixed. Okay, so under that there is a market, right? So there's a trading. Eventually, you will reach an equilibrium point. Actually, you will reach an equilibrium price. Under that price, the supply will equal to the demand. So in the economics, basically, that's called equilibrium price. Okay. So you can formulate this as an optimization problem.
One more question. Can this go negative?
What?
This utility function?
Presumably, if you make this,
The way that you define alpha is not, it doesn't.
you could, but mostly I think, even theoretical, you can't prove it's always positive, but mostly I think it's positive.
The reason I find it odd if you can go positive is because you're saying that
I don't think.
the value sense I could be making a lot of money, but my utility can still be negative.
That's a good question. I haven't, because in almost all the cases, it's always, I think, I have to think about this, but.
Sorry.
So you can formulate this as optimization problem. Okay, so this pretty straightforward. Okay, so I think I'm going to skip all this. So in the first model I present, there's no stock index future yet, right? So what I'm going to do is that now I'm going to introduce the stock index future. So one more asset. That is a combination of all the stocks you have. That's the definition of a stock index future, right? How much time I have now? 5 minutes, okay. So it's almost the same. Then you introduce a stock index future, right? Again, it's 2 period, so I can quickly, you just, because you have one more asset, you have a price for that stock index future, and I think everything is the same, right? One thing I want to remind you is that this essentially, because we assume at the end of period 2 that the stock index future becomes mature, so there is a fixed relationship between the stock index future price and the combination of the stock prices. Okay, so there's a constraint there. Okay, so let me just skip that. All the assumptions. Okay, so this is pretty. This is, so again, utility function. So this is, if there's no additional constraint, this is optimization problem with the stock index futures. Okay, so this is pretty straightforward quadratic optimization problem, right? You can get the necessary condition, right? So again, this is equilibrium price. So this is the optimization problem. And then those are the necessary conditions. Okay, you take the derivative, you introduce the Lagrange function. That's pretty standard. And based on this necessary condition, this is what you get. This is the price of the stock index futures. This is essentially a cash price. So this model says that in the perfect market, exactly the cost of carry model is correct, right? If you don't consider the dividends or those things, the price of the stock index future should be equal to the underlying assets price. Okay, so this is the first thing. Now what we're going to do is we're going to introduce some constraints, because in the previous model we assumed there's no constraints on how much you can sell by a stock, right? For example, if you can short a stock, X has to be non-negative, So if you introduce the constraint on this x, and then again you can get necessary conditions. Okay, necessary conditions, and this is what you get. Instead of q equal to this, now q is equal to this plus this extra term. So essentially, it says that under the trading constraints, now these two are not the same anymore. Okay. Now I can make it more complicated. So this is not equal. If you're familiar with the stock index future, and actually there's also margin requirement, and the margin requirement can be adjusted based on market conditions. So if you consider margin requirement, and you get the extra different terms here. Okay. Again, follow what I just did earlier. You can put down the Lagrange equation, necessary condition, and you can see that these two are not the same. So at least I have shown you that if you put the trading constraint and the market, the margin requirement, these two prices are not the same. Actually, the difference depends on those constraints and the margin requirement. Okay. Because I don't have much time, I basically want to mention that empirically, we also did an empirical study on the relationship between these two prices, the stock index future price and the cash price. You can see that because over the last 2 years, actually the Chinese regulators changed the market, the margin requirement significantly, from 10% to 40%, they reduced from 40% to 20%. So you actually can test those hypotheses. Okay, you can see the effect of a margin requirement, and also various trading restrictions on the relationship between these two prices. Okay, I hope that I also demonstrate, hopefully, that through this example, that you can actually find some interesting research problems if you actually look around. Okay. Okay. Thanks.
We are very much on time. Anyone would like to raise a question to?
So what's your explanation of that huge gap? That's due to trading restrictions?
Yes,
right?
I think eventually, people talk about liquidity. So essentially, those trading restrictions affect the market liquidity. I think this somehow to capture the relationship in some sense.
Okay, thank you.
Oh,
Oh, the question.
real quick. So this, linear combination of mean and variance is a non-coherent risk measure, right? According to this Shapiro type of definition. It potentially leads to tiny inconsistency and whatnot.
Yes.
It's basically the Markowitz model, mean variance. You can think of this alpha as the shadow price penalty for the variance. So it's difficult to say whether it's a coherent measure.
Okay, let's keep the discussion offline. Okay, thank you. Let's thank for Professor Ho.